It's actually quite an unconventional and interesting story. We are mainly into pharmaceutical manufacturing, and we manufacture pharmaceutical ingredients and fine chemicals. And we are into this business since 1952. I am the fourth generation of my family taking this forward. We never thought of getting into battery materials, but when we were developing a drug ingredient called Prussian Blue, which is an antidote for radioactive poisoning, we came across something very fascinating. Its derivative called Prussian White. And we came to know that Prussian White is one of the most promising cathode material for sodium-ion battery. So just out of curiosity, we tried to synthesize Prussian White in our chemical R&D lab. And once we had the material, we thought, why not try building a small battery? Even though we were not having any specialized equipment for battery fabrication. We had no coaters, no calendaring machine, no argon glove boxes or battery testing equipment, but we still managed to make a tiny pouch cell in our R&D lab. And when it lit up a small LED, that was a real eureka moment for us. That's when we knew we shouldn't stop here. So after about a year of refining our own synthesis process for Prussian White, we decided to set up a dedicated battery R&D lab. And now here we are. In this newly set up R&D lab, we can handle everything from synthesizing Prussian White to making and testing coin cells and pouch cells. This setup allows us to constantly improve the material, its stability, particle size, sodium content, water content, all of it. We built this lab in just 3 to 4 months, and honestly, it feels like pretty decent progress in such a short time. We have been able to synthesize cathode material that is high in quality, both in terms of stability and its core chemical characteristics, particle size, crystallinity, sodium content, all are well within desired parameters. Our cathode material is delivering a capacity of approximately 160 milliampere per gram, which is close to its theoretical capacity, and almost equivalent to lithium iron phosphate or LFP. Even in the coin cells we are fabricating right now, we are already seeing very promising results, both in capacity and in cycle stability. Sodium-ion battery technology is no longer just a research topic. Companies across China, the US and Europe have already started moving towards commercialization, and some of them are specifically working with Prussian White. By 2026, we'll likely see commercial launches of sodium-ion batteries across a range of applications. It's not theoretical anymore. It's becoming a reality, and the potential it holds is unimaginable. We are constantly improving our electrolyte, solvent and additive systems to enhance charge-discharge rate and cycle life. We expect to soon arrive at the right combination of cathode, anode and electrolyte to create a commercially viable sodium-ion battery. Our aim is to produce Prussian White at a cost of less than $3 per kilogram. And we have some very interesting strategies in place to achieve that. Given the progress we have made, we have decided to take the next step, establishing a pilot scale line for both cathode material synthesis and battery fabrication. That's our next phase of growth.